Today, our lesson is going a little bit further with the mean. We're going to be talking about finding the mean using a dot plot. Okay, so looking at the mean as a point of balance on a dot plot. And I'm sorry if you're not a KU fan, but this is a Jayhawk themed PowerPoint. All right, so we're going to be able to determine the mean using a dot plot, and we're going to be able to understand that the mean is a balance point of a dot plot. Okay, so on this dot plot, we can see that 3 would be the mean because it's the middle, right? So where could I place a dot in order to keep the balance level? If I was just going to put one dot on this dot plot, I would have to put it on the 3 in order to keep the balance from moving one direction or the other. If I place a dot over the 2, it would no longer be level, meaning 3 would no longer be the mean, right? Because if we put a dot on the 2, we're tilting this way. So with a dot over the 2, how could I make it level? Well, if there was a dot over the 2 and I went ahead and put another dot above the 4, now we're still level. Okay, we still would have the mean as a 3. Okay, so now I can calculate the mean of 2, 3, and 4 by adding them together and dividing by the number of numbers or add-ins that we have. Okay, so if we took 2 plus 3, which is 5, plus 4, which is 9, and divided it by 3 because there are 3 numbers, 9 divided by 3 is 3. So if we had a dot on the 2, a dot on the 3, a dot on the 4, we would have a mean of 3. So 3 would be the balance point. How does the balance point relate to the mean? It's the same thing. So whatever the balance point is, that's what the mean is. So if we had one on all 3, okay, the balance point is still the 3. That's the mean. All right, looking at this one here, this example, this is not in your math packet yet. When we get to your math packet, I'll show you what page we're on. If all of the dots here are on the 5, we can assume that what's going to be the mean? Probably a 5, right? So if all the dots are here on 5, that means the mean is going to be a 5. And we could calculate that by taking 5 plus 5 plus 5 plus 5 plus 5, which is 25, and dividing it by 5 because there are 5 dots. So we can still calculate mean just like we've been doing, except now we're given dots instead of the actual numbers. But we know what each of these dots are because they're all above the 5. So they're each worth 5. Okay, so what about this one? Did unleveling the data change the mean? Okay, so all we're saying here, did moving a dot to the 3 and moving a dot to the 7 from this first example, did that change what the mean is? Well, we could calculate it. We can add up 3 plus 5 plus 5 plus 5 plus 7, and we would still get 25. Okay, and 25, there's still 5 dots, so 25 divided by 5 is still going to be 5. So the mean didn't change. We moved each of these 2 dots an equal distance away from the original position, right? We skipped the 4, we skipped the 6, so the mean's going to stay the same. We're keeping it balanced. All right, this example here, what is the mean? Well, we've got 5 dots still, but now they're all on 6. So we could take 6 plus 6 plus 6 plus 6 plus 6. We would add those up and get 30. 30 divided by 5 is 6. So the mean is still, or is 6. All the dots are on the 6, so that makes sense. All right, we're going to go ahead and move 2 dots to the 2 and 2 dots to the 8. So I'm going to take 2 dots here, move it to the 2, 2 dots, move it to the 8, or to the 4, sorry. So we look like this. Okay, is the mean going to change? Is it going to change the balance point, or the mean, moving these dots? Again, we're moving 2 dots, 2 spots to the left, and we're moving 2 dots, 2 spots to the right. So because we're moving them the same distance away from the mean or the balance point, we're not changing the mean. Okay, now if we only moved one dot to the 8, okay, then our mean's probably going to change. Move one dot to the 3 and one dot to the 9. So we're going to take one dot from the 4 and move it to the 3, one dot from the 8 and move it to the 9. What's the balance point going to be? If we really have no idea, we can always calculate it. Okay, we can always take these numbers and add them up and divide by how many there are. All we're doing is finding the average and seeing if that's matching up with the balance point. So I could take 3 plus 4, which is 7, plus 6, which is 13, plus 8, which is 21, plus 9, which is 30. So I could take 30 and divide it by 5, and I would still get 6. Okay, so the balance point did not change. And it makes sense that the balance point didn't change because, again, we're moving one dot on each side an equal distance away from the mean. Okay, so some things we need to remember here. 1, the balance point remains the same when we unlevel an equal distance away from the mean. The mean remains the same. The mean is the same thing as the balance point. Okay, we can use those terms interchangeably. And the balance point is the mean. All right, finding the balance point. Okay, so now we're given 3 numbers, and we need to know, what is the balance point? Well, the balance point is the same thing as the mean. So remember, all we have to do is add up our numbers and divide by how many there are. Okay, so we've got 2 plus 2, because there are 2 2's, which is 4, plus 8, which is 12. Okay, so just keep that in mind. What number on the horizontal axis is in the exact center of this dot plot? Well, I'd say the middle number here is 5, right? Okay, but now if we calculate the mean, we already determined all 3 of these added together is 12. Okay, 12 divided by 3 is 4. So is 4 the exact center? No, and that's okay. It's not going to be the exact center every single time. Sometimes it works out, sometimes it doesn't. Okay, so don't just put a triangle around the middle number. You actually have to find the mean. Okay, so now we're going to be in our class activity packet on page 331. Okay, there are just a few problems here. I will tell you too, a lot of the problems on your assignment that I'm going to assign, there's more than one right answer. Okay, it's not just a cut and dry, this is the only model you can have. There are a lot of different options. All right, number 1, move one dot to the left and one dot to the right so the balance point remains the same. So in my notes here, okay, I'm looking at number 1. I'm going to take one of these dots and move it to the left and one dot and move it to the right. Does it say how many places to move to the left and to the right? No, but I have to keep the balance point the same. So however many places I move to the left, I probably should move that many places to the right. Okay, now I can move these to be on 3 and 5. I could move them to be on 2 and 6. I can move them to be on 1 and 7. Okay, there are 3 different options. This would be a sample answer on the PowerPoint. If you guys can see that. I don't think you can. There. Okay, that would be a sample answer to have one dot on the 2 and one dot on the 6. Now on my paper, I put one dot on the 3 and one dot on the 5. Okay. Now maybe your paper, you put one dot on the 1 and one dot on the 7. That's fine. As long as both the dots are equal distance away from the 4, then we're all right. Okay. Number 2, move all the dots so the balance point remains the same. Okay. Same type of problem, except now our balance point is 9. Okay, on number 2, now our balance point is 9. So I'm going to take one of these dots. Oh, except for it says move all the dots. Oh, shoot. So I can't leave one on the 9. Okay, so this one we're going to have to use a different strategy. So if we know we want the average to be a 9 and we have 3 numbers, then we want all 3 numbers added together to be 27, right? Because we know 27 divided by 3 equals 9. Okay, so we know that 9 plus 9 plus 9 is 27, but we need another combination. So we need to think of 3 numbers added together that would be 27. There's more than one right answer. Okay, so don't get caught up in if you're not getting the same answer as me, because there's more than one right possibility here. So in my head, I'm thinking the easiest way for me to make 27 is to put 2 dots on 10, because that would make 20, and then 1 dot on 7, because that would make 27. Okay, now I'm going to challenge you, and that's the one on your PowerPoint too. I'm going to challenge you to try and find another solution. Okay, because there's more than one other way to write that. Okay, so when I wrote that down, I put 2 dots on 10 and 1 dot on 7. Okay, number 3, move all the points so the balance point changes to a whole different number. Draw the new balance point. Okay, so you can make the new balance point anything you want. Okay, I'm going to move the new balance point. It's at 16 right now, and I'm going to move it to 17. Why am I moving it to 17? I don't know. That's just what I decided. It says anything can be the balance point, so you get to pick. Okay, now I have to move all 6 dots to a different location. So I can't leave any dots on 20, and I can't leave any dots on 12. Okay, so to make sure the balance point is 17, all I'm going to do is I'm going to put 2 dots on 16, 2 dots on 18, 1 dot on 19, and 1 dot on 15. Okay, now I'm going to make sure that I followed all the directions. So it said move all the dots. Did I move all the dots? Yes. None of them are on 20 anymore, and none of them are on 12. Did I make a new balance point? Yes. Now the new balance point is 17 instead of 16. Is this the only answer? Definitely not. There are way more possible answers. Okay, even with my balance point being 17, I could have put my dots in a whole bunch of different places, right? I could have put just 3 on 16 and 3 on 18. Okay, a lot of different options here. On the PowerPoint, they made it kind of complex. I'll zoom in here. Maybe. What's happening? I can't see. Okay, well, my computer's really dark, so I don't know. You can kind of see it there at the bottom. So they moved 3 dots there on the left. They got 1 on the 11, 13, and 14, and then 3 dots to the right. But they moved the balance point to be a 15. Okay, I would recommend not making it that complicated. All you're doing is making them have an equal distance away on the left and the right. Okay, and then the last one on this page, number 4. Move all the dots so the balance point is 6. Okay, so we want the balance point to be 6. This time we don't get to pick. This time they picked for us. So I'm going to put a triangle around the 6 because that's my new balance point. And it says to move all the dots. So I don't want any dots on 3, and any dots on 6 because I have to move all of them to a different spot. So in my mind, the easiest thing for me to do is to put 3 dots on 5 and 3 dots on 7. Now that is not the only option. That is one option. Okay. I could put 3 on 4 and 3 on 8. Just making it balanced. The sample answer on your PowerPoint, they put 1 dot on 4 and 2 dots on 5 and 2 dots on 7 and 1 dot on 8. And that works. All right. On the next page, page 332, okay, we're going to take a look at numbers 5 and 6. It says to go ahead and predict the mean before you find the mean. So I would just kind of mark underneath a number or write a number on your notebook paper just so that you can see how close you're getting to the mean. Okay, so it says go ahead and plot the points, and then we're going to find the mean. Okay, so on number 5, we've got a 10. I'm going to draw a dot above the 10. We've got a 17. We've got a 9. We've got an 18. And we've got an 11. Okay, so we should have something like this. Okay, now my job is to find the mean because right now I don't know what the balance point should be. My prediction is that it's going to be either 13 or 14 because to me those look central but yet closer to the 3 dots versus the 2 dots. Okay. All right, so I'm going to go ahead and add up. And yes, you can use a calculator. I'm going to go ahead and add up. I've got 10 plus 17 plus 9 plus 18 plus 11 to get 65. 65 divided by 5, because there are 5 numbers, equals 13. So I know the mean is 13. So I'm going to go ahead and put a triangle around the 13. So I was able to find the mean. All right. Number 6, same thing. I'm going to plot the points first. So I've got 8. I've got a 10. I've got a 7, a 5, another 10. So I'll stack it on top of the first dot, and then a 2. Okay. So this time I'm given 6 numbers in the set. So I should have 6 dots. I've got 6, so I'm good to go. Now my prediction on this one looks a little tougher for me. I'm going to go with either a 7 or an 8, maybe. We'll see. So my prediction is 7 or 8. So now I'm going to take the time here and add up my numbers and divide by 6 because there are 6 numbers. Okay, so I'm going to take 8 plus 10 plus 7 plus 5 plus 10 plus 2 to get 42 divided by 6 equals 7. So the balance point is actually 7. So all we're doing is finding mean still. We're still finding the average, but then we're drawing it on a dot plot, so we're finding the balance point. Okay. Last question, your guys' favorite, Puzzle Penguin. We haven't heard from him in a while, so let's see what he's doing here. It says, Dear math students, I was asked to decide if the balance point of a dot plot at the right was correct. The numbers to the left of the balance are on 4, 4, and 5. So far, so good, it sounds like. Which adds to 13. Okay? The numbers on the right of the balance point are 8 and 9, which add to 17. I decided the balance point is not correct because the total on one side of the balance point is not the same as the total on the other side. Can you help correct my thinking? Okay, actually, does it matter that the total on the left is different from the total on the right? These aren't weights, okay? We're not talking about measuring things out in science, or we're not talking about weights. These are all individual, we're just talking about numbers, okay? We're not thinking about this as like a legitimate balance, okay? Yes, if they were weights, he's absolutely right. We would have to have the same number of ounces, pounds, whatever we're talking about on both sides, okay? But he's actually correct. So Mr. Penguin, give yourself a pat on the back because you got this one right. Okay, so write a response to Puzzled Penguin, something along the lines of, if the dots were weights, you would be correct. However, the dots represent numbers. The sum of the 5 numbers is 30, and 30 divided by 5 is 6. So the balance point is 6. So Mr. Penguin, you are correct. All right, let me know if you guys have any questions. I'll do one more video tomorrow, and then that'll be it for the new lessons for the week. Have a great Tuesday.